This is going to be a short video. We're going to talk a little bit about all-star nodes and some things that will give you a little bit of a little insight on where you need to go to get information. First of all, I'd like to cover a few things that if you're looking to build an all-star node, there's a few things that will help you out along the way, and a few of those things are your YouTube sites where you get your information from. If you're handy with electronics, that's a plus. If you're good with soldering, that's a plus. If you have a general understanding of network issues, of electronics, Wi-Fi, AT type structured things, it'll make things a little easier. That doesn't mean you can't build an all-star node. All-star nodes can be built by pretty much anybody as long as you have the right tools and stuff to work with. I'd like to cover a few things with you on the kind of tools that I recommend you have to do these tasks. If you have the right equipment, it'll make things so much easier, because things are not always what you think they are. They can be difficult. It takes a steady hand if you're going to be soldering. A lot of the guys in ham radio, the older folks like myself, we've grew up with wire design circuits. So you're putting components, soldering directly to a terminal board or whatever, and the components kind of lay on a terminal pad and they connect up and all like that. In today's world, everything's microcircuits, so it requires a few extra tools you need to have, and some skills that would definitely help. These are a few things that I recommend you have if you're going to be building an all-star node. Okay, and a few things is, one is a soldering iron. You need a decent soldering iron with a real small pencil type tip, and the smaller the tip, the better it is for at least dealing with microcircuit type designs, which is most likely what you'll be using building all-star nodes. You have to build with the CM108, and depending on what kind of radio you use, let me pull these out real quick. 8 nodes I've built with a Bofang 888. These are very inexpensive. You're looking at a radio that costs you around $8. They're $8 a piece. If you buy them in a pack of 2, you can probably get them for 15 or less. They're very cheap, very inexpensive. They do a really good job. This is kind of the radio of choice when you build an all-star node. The one thing down from this, the one thing with this build that you will notice, that I've noticed also, depending on what you're going to use it for, and it is a 70 centimeter radio, so it broadcasts in the 440 range. And with that being said, you know, you if you're going to use it, well, we're going to get into that here in a little bit. Depending on how you're going to use it, this radio may or may not work for you, and you may need to go to a different device that I'm going to cover shortly with you. The other thing you will need, and let me show you what this is. This is the Bofang kind of opened up, and there's some soldering you got to do. You got to take the board out, and there's a COS wire that's got to be installed from the backside. You can install it from this side, but it's a lot easier just to install it from the backside. A couple of resistors you got to put in place, and you got to get some wires. It's better to kind of color code them so you know kind of where everything goes, and that is something you'll need to do, and that's where these special tools come in. This is a CM108. The CM108, there's some solder points has to be made on this chip and on this board, and these solder points are very small. And if you're going to do a CM108 by yourself, you will need one of these with the small tip and pencil tip. It's a must. And I would recommend when you're getting into removing components off the CM108 or the Bofang, you get one of these. This is a heat gun. And this heat gun's fantastic. It's great. You get it right in there where you're going to remove a component, pair of tweezers, you heat it up, and there's several videos that I've done showing you how to remove components and stuff. This is a must. You need to get one of these. Okay, this is a heat gun. Not sure exactly the actual price, but it's definitely something you want to invest in. Okay. The other thing is you will need a buck converter. Buck converter will allow you to regulate the voltage to this. Your Pi is a 5-volt device. It'll run off a 5-volt source and it'll work fine. If you're running off a 12-volt source, you need 2 of the buck converters. One to regulate the voltage to the Pi converter, to the Pi, a Raspberry Pi, and one to your Bofang 888. So you will need 2 of these. So it just depends on what you're going to be using it for. Okay. I want to cover a few other things. If you're going to be building these nodes yourself, and you want to get some good places to look to how to build one, of course you can go to our site, which is Murray Amateur Radio Club, our YouTube site that I host. The other sources that I would recommend. This is probably my most favorite. If you're starting out and building an all-star node, you've never done one before, I would recommend going to this video. It's a 5-6 part videos, and he goes into great detail on configuring the Raspberry Pi, on removing components in the Bofang, building up a CM108 and what to do on a CM108. And he just does a fantastic job, and he's very easy to understand, and you can stop his videos and get caught up and what have you. And he does a really good job. Actually, when I started cutting my teeth on the All-Star node, he was one of the guys I went to a lot. And Ben's a real good one to go to if you're starting out and when you get some understanding of building an All-Star node. The second one I would recommend is. The other one is Hayden Ham Radio DX, Kilo Delta 9, Sierra Bravo. That's his call sign. He's out of Australia. He does a real good job. Very easy to understand. Then as you advance up and you're getting into more stuff where you're designing, you're doing cloud servers and what have you. And even some other configurations. Freddie Mac's a real good one. Ham Radio Crusader. He's out of Oklahoma, and he does a great job too. So those are 3 of them that I can recommend to you right now that I really like. There's others out there I'm not crazy about. They've got a lot of videos, but they're not real clear and they jump around a lot, and it's just. I just don't care about going to those sites. So these are 3 that I would definitely recommend people to go to get some tips and learn a little bit about what they need to do. Okay. Now I like to cover a few other things. One other thing it would really be useful to you, not a must, but would be useful, is if you have a printer, 3D printer. 3D printers. You can design different things for your radios. And the new sound card is the AIOC. And I'm actually going to start using that one pretty soon to build all-star nodes. And I'll tell you why. This is, I just printed these the other day. This is actually, let me take these off I just printed these the other day. I printed 4 of them. And what you do is when you get your card, your AIOC sound card, you will need. Let me see if I can find a jack here. I don't have any handy right now. I'll put it here on the screen so you can see it. But you're going to plug in the little board into this printed device, this printed mold here, and it actually centers your pins that you're going to plug into the side of your radio. So, like every radio has a every handheld, I should say, has a port in the back where you plug your card into, or your cable to program or whatever. And this allows you to put your terminals on your board that you order and hold them in place while you solder them. This is a great little jig to use to put your pins on and solder them to your board. So that's why it's nice to have a 3D printer. Of course, you can buy these. I think they charge quite a bit online. They're cheap to make. You're probably looking at less than a quarter to make one of these, or you can buy them online at $4. $4, I think, is what they charge for them. Maybe you'll get them cheaper, but Anyway, so that's something that would be a nice tool to have if you have one, to get a 3D printer. I'm going to try to cover this as easy as I can. The Allstar node is a device that's like similar to Echolink and some of your other digital modes. And what's nice about the Allstar node is you can it didn't cost you anything to go on Allstarlink.org and register and get you some nodes. You can get the nodes; they don't cost anything. And once you do that, then you can build you an Allstar node and connect that Allstar node up to your regular radio. I use a 5100 ICOM, which has crossband repeating, and you tune your radio to a particular frequency. These are all in 70 centimeters, so you tune them in a frequency that's usable on these radios, and then once you have it all set up, you'll connect it to your ICOM or your other whatever radio you have. You put the frequency in here, and now when you key up your radio here, it triggers this Bofang, and then of course it goes out on the internet, and then you have your digital interface for that node, and it's pretty much like anything. I mean, you have D-Star, which is digital, and the digital modes are really nice. It allows you to communicate when you're out of the country or out of the state, and you can talk and keep in touch with the local guys and stuff. And it's a really nice thing to get into. It's been a lot of fun. We've had a great time with it, and it's just a lot of fun. The projects are great. They're fun to build, and you learn a lot. You learn more than you can even imagine when you start getting into the code and stuff for the Raspberry Pi and getting it programmed. One thing I didn't say about the AIOC board, which is becoming a hot topic here, is Allstar and Hamvoit use the CM108 firmware. That's pretty typical. So everything that's designed in the software of the Allstarlink is designed to work on a CM108 sound card, which is right here. And the CM108 sound card already has its firmware and everything on it. So once you get it all wired and soldered like you want it, and you plug it into your Raspberry Pi, then the wires that also go on this, which I don't have any handy right now, will hook to your Bofang like this. So these wires coming off of here will eventually get soldered onto this card. This card will plug into your Raspberry Pi, which has all the software and everything you'll need to make all this happen. So when you key up your radio, this radio will pick up that frequency, and then it will send a command over to the CM108, and the CM108 will communicate with the internet, and then it transfers it out to the receiving radio and receiving frequency, and then you have communication take place. So this new thing here that they're really getting into, the AIOC, is a card similar to this, but what it allows you to do, it has a chip on board that allows you to program the firmware into it that makes the Allstarlink node think it has a CM108. So that's what's nice about this card. And what's cool about that card is now it plugs in. You can grab any radio, any handy talkie that has the ports in the side for the mic, which is pretty typical with any of the handy talkies. So you plug it in here, and of course the board is right on that plug, and then it would connect up through a cable over to your Raspberry Pi, and the Raspberry Pi, of course, will connect with Allstar, and Allstar node, your Allstar node in particular, and now you're talking. The downside with this configuration, with plugging it in here, is the card is right here. Your antenna is right here. So what happens is when it keys itself up, the broadcast from that frequency has a tendency to pick up the noise gets picked up by the sound card, and you get some noise that's carried through your transmission. To get rid of that problem, other than putting it in some kind of a metal container that's grounded, that closes, that protects it and shields it from outside noise, is to use the new revised AIOC, called AIOB, and it's a card that'll have cables that you solder to it with the plugs that go into here, but the board is away from the radio, so you don't get that noise. That makes that a much better way to go, and that is going to be my next project, is getting the AIOB and using that to make my audio board to hook to my Raspberry Pi to work with all my Allstar nodes. And that's coming soon. I will have a video on that when I get it. I'm still trying to find a good price on those. Those boards right now, being that they're scarce, is running in the neighborhood. I think the cheapest I've seen is like $34, if you can get one. They're usually out of stock. But I plan on getting one of those cards, and if I get one, then I'll build one, and I'll do a video on it, and you'll be able to see it. So, getting back to options, we have several options. We can always go with a Bofang 888 or a comparable radio that you can tear apart and you can configure like the 888. And the CM108 that plugs into the Raspberry Pi that connects to your Bofang. That's one way to build Allstar nodes. I built 8 of those, and they work really well. The next thing would be to go ahead and get the AI. Still having trouble with remembering that. The AIOC, or in my case, the OB, which is better because the board isn't next to the radio; it's away from the radio. That is a better option in my book, because you move that card away, you won't pick up that interference from the antenna on the radio itself. So that would be the way to go. And like I said, with the new card that we're going to be getting hold of, it allows you to hook your radio, any kind of radio that you have, which I have several. It allows you to plug them in, and then you gain one thing that I don't have with the Bofangs. The Bofangs are all 70 centimeters. These allow you to do dual band, so you got UHF and VHF, and 2 meter or 70 centimeter, and it allows you to get some benefit from that by using that. Also, if you're doing crossband repeating, which I do quite a bit, we have a radio that communicates directly with our local repeater, and it allows us to connect to the repeater and join meetings and what have you from out of the state, which is great, or out of the area for that matter. But I can only crossband with my local repeater, which is on 2 meters. If you decide to get on another repeater that's on the 70 centimeter, now you have a problem, because you need a radio that broadcasts in 2 meters and crossbands over to 70 centimeters. I don't know if that makes any sense. Hopefully it does. But that's a really nice option to have, and that would be the way to go. Plus one thing you gain with the AIOC or the AIOB is you don't have to tear the radio apart like this here and wire things in and remove components. You have to take out a final in here and some other things, a coil and different things. You don't have to modify the radio at all. And the only thing you really have to do to the the AIOC is program it, put the firmware in it and program it. And once you program it, it's just a matter of plugging into the USB port, and then the other end of that board that you plug in will go to your USB cable that, or your USB cable that plugs into your Raspberry Pi, and then all the magic's done on the Raspberry and communicates with the AIOC or AIOB, and then takes care of the internet communication issue, and you're up and running. Anyway, I hope that was clear as mud. And I always get upset when I watch videos and they ramble, and I probably rambled a lot, and I hope that's not the case. I hope I made some sense and didn't go off base too much. This was not a build video. This is strictly informational video. Give you some ideas of where you might want to go with your All-Star node. There's many options out there now, and there's a new option with this the AIOC and the AIOB. Having that option changes a whole lot of stuff if you can get one. One thing I will tell you, if you build the old design that I built a lot of, and I'm very comfortable with, if you do this option, this is cheap. You're looking at the biggest cost you're going to have to the whole build is the Raspberry Pi. Raspberry Pi 3 will cost you, 40 bucks or less. And of course, the 4 and the 5, they go up from there. But if you can get you can build these with the 3. They work great with the 3 Raspberry Pi 3B. And I built most of mine with the 3B, and it works fine, no problem at all. The sound card and the radio, the Bofang, $10 maybe. How much costs it all? You gotta shop around to get these. Some places would charge you $8, $10, $12 per card, but I buy them in bulk and you get them for a couple bucks a piece. And the buck converter, a few bucks a piece. So this stuff's all pretty cheap. So you're not out a lot of money. Of course, you'll need to get a card, get some microchips. 32 gig at Walmart, $8.96 for 2 of them. They work great. They recommend getting one some higher end memory chips, because if they shut down a lot, they'll crash and stuff like that. That does happen. I haven't had any trouble with these, and they're cheap. And what I always do, I have a backup. So when you get one that works well, make a copy of it, and make sure you back it up through the internet or however you can back it up. And you'll always have something you can swap to if it crashes and burns. But I haven't had any of these act up on me at all. I'm not saying it couldn't, but it's cheap. You get 2 of them. Like I say, 2 of them, 32 gig for $8.96. That's pretty cheap, and they do a really good job. That's just one option. There's many out there. SanDisk makes the good ones. These chips are pretty cheap now, so they don't break the bank. So with everything being said, all the components you'll need to build an All-Star node, with the going prices, I would say less than $70. You may go up a little bit depending on the availability of components. It may go up on you. If that's the case, you may go up to $100 per device. In most cases, $70 is probably safe bet, 70 or less to build an All-Star node. You will need some resistors and some 3904 transistors for this build, for this particular build. So you got to keep that in mind. That's inexpensive parts too. You can get a whole transistor kit that's got 3904s in about 20. I think it's got 20 of them in there or something. and those are less than $12 for the whole box of different assorted ones. And resistors are cheap. So you will need some of those components, but most of that stuff is once you buy them, you'll have enough to last you for a long time. So it's that first initial investment you'll have to spend. If you go with the ladder we just talked about, the AIOC board, that board's going to cost you more money up in the front end, but there's no other secondary components you'll need. Once you buy this, the only thing that is going to be involved here would be any wiring to get to the Raspberry Pi, the USB cable. There's no components to put on them at all. It's all software. It's all programmable. Everything is in the software. So really no other components you have to add to this device. So you can go that route and save yourself a lot of aggravation. I think that's all to cover in this video. I like I say, I hope that was clear. I hope I didn't ramble too much. Just remember, think everything through when you decide to build. Make sure if you don't have steady hand, shake a lot, or it's just not something you can do comfortably. Get somebody else to do it if you can. If not, you can't get the parts already done. You can buy these CM108s already modified. I think it raises your price by $20 maybe. So if you get one already modified, you may have to pay somebody $20 to modify it for you, maybe more. But that's kind of what I've seen. Somebody will charge $20 to mod one for you. It's not that hard. It's just it requires a steady hand and the right tools. The radio is the same way. There's a few components in the radio that can be difficult to remove, especially on the back side of the board, which I'm not going to take this one apart right now, but you got to flip the board over and remove the final. There's a final in there that's got to be removed. You really don't have to remove the final. You can leave it in, but it's just better to take it out. You don't need anything high power. You just need milliwatts, and it works great without the final. So you take the final out, and there's a coil you remove and a couple resistors in the back end. If you have one of these, it's a piece of cake. So just remember the tools and stuff that makes the job easy. If you get one of these, make sure you got a good iron. I've got some workstations and stuff. I use this one more often because it's just got everything I need. I don't have to bring out a big workstation. I don't have to go to my outbuilding to take stuff out there. I do everything right here on my desk, and this works great. Other than that, that'll be a wrap. And I hope you enjoyed it. And if you decide to get into ham radio and you're local to Columbia, Tennessee, we welcome you to join our club, Murray Amateur Radio Club, and we're on 147 120 frequency, and we meet at 8:00, and we have some other meetings that are available too. I think if you go to our dashboard, and I'll put that in the description, and all the information you'll need to get to the different meetings and stuff, and our frequency, call sign, and the tone. Just remember, you're welcome anytime to join our club and to join in online, or on the radio. Anyway, have a great day. Thanks for watching, and we'll see you again soon.